York to California, a quiet revolution is taking place. The transformation of internal combustion cars to electric power. It's a technology both environmentally sound and economically encouraging. Electric power-driven vehicles, like this one, can change the sound on the nation's roadways, as well as improve the quality of the air. It's happening now on streets and highways all over the country. A quiet revolution. Statistics tell us that 70% of all cars travel less than 30 miles a day, to work and back, to the store for groceries, and to other locations for errands. With the benefit of fuel economy and pollution-free travel, zero-emission transportation is here, and it's being used by more and more car owners as the conversion technology has advanced and as this knowledge is made available to drivers everywhere. We're going to follow the conversion of a GMC S15 Pickup. We'll answer questions about the conversion process, and we'll talk to involved people along the way. Our guide on the journey is Mary Ann Chapman, president of Eco Electric Corporation of Tucson, Arizona.
I've been involved with cars off and on most of my life, and I've also been very concerned with environmental problems. In fact, I was very active in environmental education for several years. I realized that I could combine both interests by becoming involved with electric vehicles. So I located some other folks who were interested, and we got together and formed the Tucson Electric Vehicle Association and started raising public awareness in the Tucson area. Then I found some sponsors and converted the Chevy Love pickup and drove it in the Solar and Electric 500 race in Phoenix. Since then, I've done a lot of investigation to find out the very latest and best techniques and components that are available for conversions, and I've formed Eco Electric Corporation to do conversions for other people and companies. I've been joined today by Rich Cunningham. About 20 years ago, Rich built an electric truck for himself. Back then, he didn't have the advantages of the mass-produced components that we use today. So he thought he'd like to follow the conversion of this GMC S15 from beginning to end and see how we do it now.
Yeah, I'm real excited to see how you're doing it different these days, and I have a million questions.
Okay, Rich, what do you want to know?
Well, my first question would be, how much does it cost to completely convert a vehicle?
Well, there's a wide range of cost. It can be as low as about $8,000 or $9,000 or up to $12,000 or $13,000 if you have a company like mine do it for you. That range depends on what kind of vehicle it is and the options you choose. If you want to try doing it yourself, it can be as low as $2,500 or $3,000 if you use used parts and you shop around and get everything down as low cost as you can.
Well, Mary Ann, how many hours does it take to make the conversion?
Again, that varies a lot. Some of the suppliers are putting out kits now that they say you can install in about 40 hours. The average seems to be around 150 hours to 200, and maybe a little more if you're having to do a lot of fabrication. The range depends on, again, what type of vehicle it is and how much fabrication you have to do, if you have to build battery racks and so forth.
So once the vehicle is converted, what's the actual cost of operation?
Depends on the cost of electricity where you live. Most people say if they drive the car every day, their electric bill goes up about $40 a month. I would say average the cost is about 50 to 85% of the cost of running with gasoline.
Well, what about maintenance costs?
Well, that's where the real savings come in, because there's virtually no maintenance. About once a month you check the water in the batteries, make sure all the connections are tight, but there are no tune-ups, oil changes, mufflers to replace, like that one. And so you have a real savings on maintenance.
So where do you do the conversions?
Come on inside, I'll show you the shop.
Okay.
Well, Rich, here's where it all happens.
Well, this is certainly the cleanest shop I've ever seen.
Yeah, about a year ago we were doing general automotive work in here, and it was a real grease pit, but we've cleaned it up, painted it white, and turned it into a real electric vehicle hospital environment.
It certainly looks like you've got everything you could possibly ever need to make an electric vehicle conversion. What's your next project?
The Arizona Electric Power Co-op has contracted with us to convert one of the trucks in their fleet, and we'll be starting on that soon.
I see. Well, you can't possibly do the total conversion yourself.
Well, I could, but not in the time allowed for this project, so I'm going to have two guys helping me with it. Dee Evans is an electrical engineer, and he helps a lot with the design, and he's also very good at fabrication, so he'll be doing a lot of the cutting and welding and some of the other aspects of the project. Chuck Johnson is an electronics technician, so he contributes to the design effort and also helps me with a lot of the wiring and pretty much whatever else I need when I need an extra hand.
Mm-hmm. When does this project get started?
Well, they should deliver the truck to me tomorrow morning. If so, we'll take it and get it weighed during the afternoon and probably be pulling it in late in the day. Would you like to come by after work?
Oh, I'd love to.
Great.
Super. I'll see you tomorrow.
Okay. We're going to remove a heavy engine and add some heavy batteries, and we need to position them such that the weight distribution on the completed truck is about the way it was when we started. First thing we do is take the truck to a metal salvage yard and weigh the front end, the rear end, and the overall truck, and then we can calculate where we want to put the batteries. Because we care about the environment, we want to make sure that we don't release Freon into the atmosphere when we pull the air conditioner off the truck. The way we prevent this is by taking the truck to a shop that has the proper air conditioning Freon recycling equipment. They will attach the equipment to this valve and pump all the Freon out, and then we can get on with pulling the air conditioning without any danger to the earth.
Hi, Marianne.
Hi, Mary.
Hi, Rich. Hi, Dee. Well, this is the truck we're going to be converting for the event in L.A. It's a GMC S15, which is the same thing as the Chevy S10. And this morning we went to the metal salvage yard and we weighed it. We weighed the front axle and the rear axle, and plus we also got a weight for the overall truck. Now the next thing we need to do is measure the height of the wheel well opening with the gas-powered motor in it.
I see. Well, why do you do that?
Well, we're going to be adding 3/4 of a ton of batteries to this vehicle, and the vehicle was designed to operate correctly at a certain height so that the suspension would work the way it's supposed to. And when we add that much weight to it, we're going to have to add a leaf spring to the springs in the back. A pickup is designed to have a payload in the back so we can handle some additional weight, and it's designed with the bearings and the brakes and so forth to handle that. If we were doing a car, we'd want to select a car that has a pickup or a van or a station wagon version of that vehicle design that has heavier brakes and suspension and bearings and so forth. But this pickup is designed to have that additional load capacity. So we give it our best guess by adding a leaf spring to it and measuring the height ahead of time, but it really needs to end up just right.
Well, what happens, Marianne, on this truck if it doesn't end up the right height even after that?
Well, we can always put air shocks on it or coilover shocks, which give you the ability to adjust it a little bit so that we can get it just like it's supposed to be.
Oh, I see. Okay, well then I'll get out of your way and let you measure it.
Okay.
Marianne, let's measure the ride height at the center of the front wheel well. Looks like it's 74 centimeters.
Good. Okay, now let's do the back.
Okay.
Okay, and at the back, the ride height's 82 centimeters.
Rich, are we ready to pull this gas-guzzling, pollution-belching hunk of iron out of here?
Yeah, sounds good. Let's do it.
Okay. First thing we need to do is pull the hood off. And before we do that, we want to mark the position of the hood hinges so that when we put it back on, it'll go on right into position real easily. So I just take this pencil and mark that. And Chuck's standing by with his butterfly wrench. I'll hold it. Wait, whoops, one thing, we got to put this towel in here so that we won't mess up the paint when the hood falls down. There you go. Okay, I'll hold the hood while he takes those bolts out. we've disconnected the various parts, we've been careful to label everything so that when we put the truck back together with electric power, we'll know which wires to attach to which components. There are always a lot more things to disconnect than you would think.
I don't know, Mary Ann. I came over to pick up a flyer on electric vehicles, and I just got so excited about this project that I couldn't help but get involved.
Yeah, Rich, you've been under the car half of the day, I think.
Oh, I'm glad he came. Saved some knuckle skin for me.
Yeah, I got a skin knuckle myself. Well, we're pretty tired and greasy and grungy, but we've been at this most of the day. We about have this thing ready to come out, don't we?
I do believe so.
You know, we've been checking our work list as we go. Why don't we take one last look and make sure everything has been disconnected before we take the motor mounts off?
It's a good idea.
Well, let's see. We already crossed off some things that we had done before we started pulling the engine. First thing we did this afternoon is we disconnected and removed the battery so we wouldn't have any sparks flying while we did everything else. We disconnected all the wires going to the engine and labeled them with little masking tape labels. Then we disconnected all the fuel lines and stuck bolts in the ends of them so they'd be plugged up, we don't have gasoline running around. We disconnected the lines to the power steering. We haven't removed the carburetor linkage yet because we want to make a measurement on that before we do it. We drained the cooling into a container, and everything that we drain we put in a container like this to take to the recycling. We want to be ecologically correct here. And we drained the power steering fluid also. We removed the grill and the radiator. We removed all the air conditioning hoses, and we plugged those up too so that they won't get trash in them while we're working on the car. Removed the air conditioning condenser core. We decided to leave the radiator core support on because we may be able to get the motor out with it on, and it'll make it a lot easier for us later on. We did remove the shift lever. We got the vehicle up on jack stands, and we drained the engine and oil again into one of these recycle containers. We've disconnected the clutch cable and slave cylinder and the speedometer cable and some wires that were going to the transmission, and we labeled those. Everything we disconnect, do we want to know later what it is, we'd be sure to put a label on. Then we put a pan under the truck so we catch the rest of the transmission oil, and when we pull the drive shaft out of it, we pull the drive shaft out. We've got the exhaust system disconnected. We've done all those things, haven't we, guys?
You sure have.
Okay, so I guess we're ready to take some measurements, and then we'll pull the motor out. Now, Rich, when we get the electric motor in here, the throttle cable will be connected to the electronics, and we need some way to know whether we're getting full throttle. So we're going to measure what constitutes full throttle now, and then we'll be able to check it when we get the electric motor in.
Okay. Chuck, you're in the cab there. Would you step on the throttle clear down? Okay, that looks good. Okay, clear up. Okay. All right, that looks like 1 11/16 travel.
Okay.
Okay, now we're going to need to know the angle of the transmission once we pull the engine and the engine mounts are gone. So to establish that, it's kind of tight down here and hard to get down and measure down there. So we're just going to put a 1-foot ruler in there, put it right against the firewall, and just put a mark at the top of the ruler on the firewall. Okay, that'll make it easy to get that transmission back where it goes.
Now, how about for a double check on that angle? Let's check the angle that the valve covers are at right now.
Okay, got one here. I pulled off my ruler. All right. Looks like 5 degrees, Marianne.
Okay, that'll do. The last measurement we want to take is how this gasoline-powered motor is centered in the car so that when we get the electric motor in, it'll be pointed in the same direction. Dee's going to do that by putting a square in and actually marking on the truck where each side of the motor is, and then when the electric motor gets in there, we can just make sure it's pointed the same way. Okay, I guess we're done with everything we need to do here. Let's get those motor mount bolts undone, and Chuck, roll the cherry picker on over here. This handy motor hoist that we call a cherry picker can easily pull this engine out because it can lift up to 2 tons.
Just dropped. I just came forward.
Sounds fine. A bolt was fine. On the
Hang on.
gear shift.
We're hanging on the starter. Can we push it this way so? There you go.
Okay.
Let's get some hands.
Yeah.
Hang on, hang on. Okay. We're all right.
Maneuvering the engine around all the obstacles can be tricky, and this is where teamwork really comes in. This team works real well together. With some vehicles, it's necessary to take out the radiator core support, but we could see we could get the engine over this one, so we left it in so it would be easier to reassemble the truck later. Our team worked some long hours because we were invited to take the truck to do a conversion demonstration in California, and we wanted to be about half complete before we left.
Hang on, let me get a little higher. All right, that's it. That's it. Hold on, hold on.
We won't have to listen to this dinosaur anymore. Well, Dee, you know what the good news is now. In the morning, I'll take this thing to the steam cleaners, get all this crud cleaned off, and we'll steam clean the engine compartment of the truck, and there'll never be any grease in this truck again. It's clean from now on.
Well, I don't know if that's good news. Then my job starts. I've got to design this adapter plate.
That's right, that's the next step. We'll take the transmission off the engine and start that design process. You want to be here like after lunch tomorrow?
Sounds good.
Okay, and Chuck can take his grease monkey hat off and put his electronic technician hat on, and we'll get this thing designed.
What I've got so far, here's a composite drawing of the whole assembly.
Let's zoom in on that tricky motor coupler.
Okay. Okay, Marianne, here's the close-up of the motor coupler. Here's the transmission shaft and the motor coupler itself. And you can see a little bit of the flywheel here in this zoom in. And I'll show you how I arrived at this design. Okay, Marianne, I took dimensions of the transmission here and the bell housing and the shaft and the size and shape of the flywheel and where it went, and entered that into the computer. It makes it real easy using a drafting program on the computer. And then I measured the motor and its shape and dimensions and the motor shaft, and put that in the computer here on the same center line as the transmission shaft, a little bit of space in between there. And then I could design the transmission plate and the motor plate that mount the motor to the bell housing of the transmission. Then once I have the flywheel in place and the transmission shaft and the motor shaft there, then I can design the motor coupler and the keyway that goes through it, and the set screws and the bolts to mount the transmission, the flywheel.
That's terrific, Dee. Now there's one more job we need to do on your computer. When Bob Batson sent us the schematic from Electric Vehicles of America, it was nice and clean, but we've made a few changes and added all the gauges, and it's kind of a messy working drawing now, so I think it'd be a good idea if we put it on your computer and cleaned it up.
All right, sounds good.
Now it's time to start fabricating the motor cradle and battery racks. These items are designed specifically for each make and model of vehicle. The racks are carefully designed to hold the batteries securely in the vehicle and keep them from shifting in case of an accident. They're sealed at the bottom to contain any acid which might ever spill. When we convert trucks, we put the batteries under the bed, or most of the batteries anyway, to lower the center of gravity and improve the handling. When batteries are inside a passenger car, the boxes are totally sealed so that hydrogen gas, which generates while they're being charged, can be vented outside the car. That's an important safety measure with a passenger car. In the pickup, the batteries are under the bed in the hood and outside the passenger space, so we just cover them with neoprene for safety to keep you away from the high voltage.
Hi, Mary Ann.
Hi, Rich.
What's the project for today?
We're working on the battery racks, making them out of this steel angle iron.
Oh, I see. Oh, I see you already have the tilt bed installed too.
Oh yeah, it's really neat. Come take a look.
This is really neat. What's the idea?
Dee designed this so that the bumper could tilt with the bed. A lot of times when people build electric trucks, they just pull the bumper off so that they can make the bed tilt. But what Dee did was design this so that this piece of square tubing strengthens the bed. It's bolted to the bed here and welded to it down here, and then there's a piece of half-inch plate welded to the inside of this frame rail, which strengthens the frame rail, and these plates here are bolted to the bumper. So he's turned the bumper mount into a tilt bed mechanism.
Oh, I see, and then it just pivots on this bolt.
Right, this is a bolt we've just stuck in here temporarily, but when we finish we'll put a hardened pin in it.
Oh, I see. And I suppose that's a battery rack that you're sitting in now.
Right, come take a look at these battery racks. There are 4 battery racks here. They're all made out of 1/8" steel angle iron. And there'll be 6 batteries here, 6 there, 4 in the back, and 4 under the hood.
A picture of a truck in a magazine that had been converted, and they had put all the batteries right in the back of the bed. And you've gone to a lot of trouble to get the batteries under the bed. What's the reason for that?
Well, it lowers the weight. It makes the weight distribution of the truck lower, and that makes it handle better. And also, then you have your whole bed that you can still use for cargo.
Oh, I see. And these 2x4s you're taking to California with you?
Well, that's another temporary measure, you know, construction. We're still under construction. When we're toward the end, we'll make a permanent support to hold the bed up when it's tilted up.
Oh, good.
Hello? Oh, hi, Rich. Oh, you can't make it today? Well, I'm sorry. Yeah, well, you know, I'm glad you called, though, because I wanted to talk to you. Remember I told you about that event in L.A. that we're going to take the truck out to, the International Electric Grand Prix? Well, we're making our plans. It's coming up in about a week, and it's going to be a lot of fun, and I thought maybe you'd like to go along. There are going to be a lot of different electric vehicles there you can see, and we'll have the truck there doing a demonstration on how you convert an electric vehicle. Yeah. Okay, well, great. Check your schedule. I hope you can make it. Okay, well, maybe you can come by tomorrow when we're working. Okay, see you later. Bye. Well, here we are in California at the first International Electric Grand Prix. It's a showcase to let people in Southern California see what electric vehicles are all about. The organizers of the Grand Prix asked us to demonstrate to people attending it how a vehicle is converted. So we transported most of the equipment from our shop out here, and we're proceeding with the next steps in the conversion. Earlier you saw Dee designing the adapter plate on the computer. Now here's the completed plate with the motor attached to one side and the transmission on the other. So now we're ready to install it in the truck. This assembly is lighter than the one we pulled out, and putting it back in is much simpler and cleaner. Now that it's in, Chuck is under the truck attaching the transmission and the drive shaft.
Let looking first and let. That used to be a normal car, now you just change it, or what? To
Yes, used to be gas.
Events like this are exciting to me because they give people an opportunity to see that electric vehicles are a thing of today, not just of the future. At the Grand Prix, we even talked to children who had school assignments to gather information about electric vehicles.
I think one of the most exciting parts of the rally for me was the opportunity to actually see a number of working vehicles and talk to the people who built, designed, and drove them. I could see there was a lot of excitement in the industry now, and I could actually learn a lot about the new technology that was involved in a number of different types of alternative power vehicles. And without a doubt, these were people who felt really good about the zero-emission situation and the part they played in helping the environment.
Well, we're back at Tucson. We've rested up from that long trip, and we're ready to get back to work on this truck and get it rolling. Well, now you can see that we've painted the frame a nice shiny black so it'll look good when the bed is up. We've installed the batteries in these 3 racks in the back with in their welded polypropylene boxes, and they're all cabled together, and besides just the cables, we put terminal covers on each one so that if anybody gets their hands in here, they won't be able to get into contact with the high voltage. We're also going to put neoprene covers on each rack so that there'll be additional safety from the high voltage. Each of these racks is cabled together with cables running between them, and the next thing we need to do is then run the cables on toward the front. So we have cables running from the positive side of this battery down and under the truck, and from the negative side of this battery there's a cable running under the truck. Now, when those cables run into the truck, we have to be very careful that they can't fray by rubbing against anything that's under there. What people in cooler parts of the country do is run them through conduit, but here we're in hot climates like Arizona. We're very concerned with keeping the heat down. Cables running through conduit can heat up a little bit, and that will cause more resistance and impede the flow of current. So what we want to do here is, instead of running them through conduit, we're going to establish a safe route where they can't come in contact with anything sharp, and secure them into position in that route with these insulated cable clamps. So the next thing I'm going to do, and the reason the car is jacked up, the truck is jacked up in the air, is that I'm going to get under there on a creeper and screw all these cable clamps to the underside of the truck to hold the cable in place. Sometimes it's difficult to route the cable exactly where you would like it to be, but as long as it's held securely in place so that it can't move and fray, you should be in good shape. Anytime you get under a truck like this, you want to make sure that you not only have it jacked in the air, but you have it on jack stands for safety. All of the batteries and the high voltage components have to be connected with cables that are made up with required connectors on the ends. The first step is to cut the cable to the desired length with these cable shears. First thing we need to do is trim about 1 inch of the rubber off, taking great care not to cut through any of the copper. We're just cutting the rubber off. Now, it's going to be a very tight fit into the lugs, so you want to be real careful to keep the little fine wires inside all together as you pull it off. And you do that by holding it very tightly and twisting it in the direction that the wire is twisted inside. Okay, now we have it off. There's also a plastic coating inside. This time it came off with it. Sometimes you have to go back and trim it. And we'll trim this off. We take this Norlox anti-corrosion compound, put some inside the lug. I'm finding that it takes about 1 bottle of this to do a whole truck, 120 volt truck, which has a lot of batteries. Now again, it's good to put some around the edge of the cable. Now, some of these lugs are tighter than others. These particular ones are very tight, so with luck we'll get it on the first try. Make sure the wires are all going the same direction. And you twist the lug as you put it down on there. Right. And keep twisting until you get it all the way down. Okay, it's down. Yep, these sometimes tend to twist, so what I do is make a mark on the lug and on the wire so I can make sure it's not twisting on me. Then we take these big old crimpers, which I happen to own these since I'm in the business, but if you don't own a pair, you can probably borrow them from your battery supplier. Tell him I said so. And you really should use crimpers like this and not the old chisel and hammer method that some old-timers will tell you works as well. It doesn't work as well. You really need to use the crimpers. You see, it's set to 2/0. It's set to the size we need, and you put it on, and you want to put 2 crimps. The second one will be right at the very bottom, and the first one will be up a little higher. So you do the higher one first. Some lugs actually have lines showing you where to put them. This particular one doesn't, but I know where to put it. Okay, get it on there, and then we tighten it down. I'm going to have to back up to do this. Okay. Now, there's 1 crimp. And my lines are still lined up. So we'll do the second crimp. If the connections are left open to the air, they can corrode, and that can cause problems because of resistance and overheating. So we seal them up with heat shrink. This is a special heat shrink that has a resin on the inside. It will melt and seal the shrink to the cable. We cut a piece of shrink 1.5 inches long so that there will be 3/4 of an inch on the cable and 3/4 on the connector. Okay, now we're seeing how this fits, and I've fastened it on there to the controller, and we'll come around here and fasten it onto the contactor. And that looks like it's just about right. Let's take a look at the high voltage components of the electric vehicle system. All of these components carry up to 400 amps of current at 120 volts. So if you could get your hands on them while the current was flowing through them, it could be very dangerous. So we've gathered them all together on this aluminum plate, and we're going to build a welded polypropylene cover that covers this end of the plate plus the circuit breaker to keep these connections out of the reach of curious fingers. Probably the most important component is the controller. This particular one is made by Curtis. The controller serves a very similar function to that of the carburetor in a gas-powered car. it controls how much fuel gets to the motor. In this case, it receives a signal from the throttle from which it determines how much electricity should be flowing from the batteries to the motor, and it releases that much electricity to the motor. Controllers tend to run hot, so this aluminum plate serves a dual function. It serves as a heat sink or a way to dissipate the heat from the controller. The heat is conducted to the aluminum plate, and from there it gets dissipated. Also, we have a finned heat sink under the aluminum plate, which further dissipates the heat. This is a circuit breaker. It's very similar to the one in your house. If there's an extra high surge of power through the system, it will automatically trip off. Also, it will be connected with the inside of the truck through a cable very similar to a choke cable, and if the driver perceives a situation of any sort and wants to immediately cut off the power, all they have to do is pull that choke cable and it'll trip off. These devices are called contactors because inside each one there is a set of electrical contacts. When the contacts are closed, power can flow through the contacts and through that contactor. When they're open, power can't flow. This particular one will be attached to the key switch so that when the driver turns the key, these contacts will close and power can flow through them. However, power still can't flow through the entire circuit until these close, and this contactor will be connected to the throttle. So when the driver presses the throttle pedal, these contacts will close. When the throttle pedal is up, these will open. So power will only be able to flow through the entire system when the throttle is pressed. So there are three ways that the system can be shut down. One is by getting off the throttle, one is by turning the switch off, and then we also have the circuit breaker. The final high voltage component on the plate is the shunt. The shunt is a device that introduces resistance into the circuit, which allows you to accurately display on the ammeter the amperage that's currently flowing through the circuit. The ammeter that we're using has two scales on it, one from 0 to 500 amps to show the motor amperage, and one from 0 to 50 amps, which is used when the car is charging. That shows how many amps are going from the charger into the batteries. This big shunt is for the higher scale, and for that lower amperage scale we need another little shunt to accurately read that. So that one will be on the plate too. KTA Services makes these nice dual scale backlit gauges. The other one that we're going to have mounted in the cab of the truck is this voltmeter. The top scale is the voltage that's currently in the power pack of 6-volt batteries. It goes up to 150 volts, and it should usually read somewhere around 120 or a little higher. The lower scale, it goes up to 14 volts, and it will be used to monitor the 12-volt battery that runs the accessories on the truck, the lights and windshield wipers and so forth. Now let's look at the underside of the aluminum plate. This device is called a potentiometer box or a pot box. Inside it is a variable resistor. The throttle cable will come in through this bracket, through this hole in the bracket, and be connected to this lever, and when you press the throttle pedal, the cable will pull the lever, and the variable resistor can detect the motion of the lever, and then it will send a signal through this cable, which will be stuck through this hole in the plate and connected to the controller. And the signal goes to the controller, and that's what tells the controller how much electricity to send to the motor. Then the other thing on the bottom of the plate is this finned heat sink, which helps to dissipate the heat of the controller, which we referred to earlier. The entire plate will be isolated from the battery rack that it sits on by a neoprene strip that will be cemented to the plate across the side where it rests on the battery rack. In addition, the bolt that actually goes through the plate and attaches it to the battery rack will be isolated by the rubber on these isolating nuts, which we can use to connect the plate to the battery with the bolt. Now that we have the cable securely fastened in position under the truck, we'll find the end of this one, bring it up, and it's a little long, so we'll have to cut it to the correct length, attach one of these lugs to it, and then it will come up through the plate and fasten to this bottom terminal on the contactor. Then we'll find this end over here. Okay, bring it up, and again we'll have to cut it to length. This one will connect with the first battery in this battery rack, so it needs a battery type terminal and a terminal cover, and then we're ready to connect it to the batteries. One safety note here, you may have noticed that I have the ends of these cables taped up, and under the tape there's a small piece of neoprene to offer a little additional insulation. The reason is because we have the batteries all cabled together in the back, and if these cables touched, it would complete the circuit, and we don't want to do that yet. So to prevent an accident, I have them taped up. That's always a good idea to make sure that nothing connects before you're ready. Another thing you may notice is that I have no rings or bracelets or metal watch bands on, because if anything metal accidentally hits some electricity, you could get a bad burn or maybe even amputate a finger. So all the safety precautions like that are very important when working with electric vehicles. Rich, the last time you saw this high voltage plate, we had mounted the components and connected them together with the high voltage cables. Now we've added the smaller wires that control the operation of the controller and the contactors, those white wires that feed the gauges, and we've connected the whole thing to the original ignition wiring, which will enable us to use the key in the cab to turn on that contactor that's controlled by the key switch. Chuck, what else have we done?
Well, we've reinstalled the 12-volt battery and installed a 12-volt charger for it here on this wheel well. On the opposite wheel well, we have installed the high voltage 120-volt charger. Being that we eliminated the alternator when we pulled the gas engine, our problem here is keeping the 12-volt battery charged. We take care of that by installing a 12-volt charger, which runs off of 120 volts AC from the other high voltage charger. It converts it to 12-volt DC and supplies it to the battery through these wires. And then we just distribute it back through the system through the original 12-volt wires that came with the truck.
You see a lot of cables and wiring here on top of the high voltage plate. I'll explain to you what a few of the more important ones are. First, the battery circuit. The cable from the most positive battery, from the positive side of the battery pack, comes up through this hole in the plate and connects to the bottom side of the throttle contactor. The negative side of the battery pack comes up into the circuit breaker and through this cable to the top side of the key contactor. Then when both of these contactors are closed, the circuit is complete. The pot box, which is under the battery, under the high voltage plate here, is controlled by the throttle, and it sends a signal up through this wire into the controller. The controller then decides, computes how much power should go to the motor. That power comes out through this cable, through this shunt, and down through this hole in the high voltage plate to the motor. This cable here is the positive side of the high voltage, and the positive connection to the motor is through this cable here. These shunts are in the system to read the current that's passing through at any particular time and provide a reading to the gauges that they can then display. We have two shunts in here because we have a dual scale ammeter. This shunt reads the charging current when the battery is charging. This shunt reads the current when the motor is operating. You'll see each wire is carefully color-coded to show its function. This relay is wired to switch back and forth between the two shunts, depending on whether we're currently charging or operating the motor. The yellow wiring is the pot box wiring, and you'll see we have a couple of fuses in for safety. And finally, these two wires here are from the original ignition wiring on the truck. They control the key contactor. I think we're about ready to start testing the system. So Chuck, turn on the key and let's see if that contactor closes as it's supposed to. All right.
We decided upon a transformerless charger to reduce the added weight to the vehicle. There are 2 electric vehicle parts suppliers that we know of that supply these type of chargers. One is KTA Services, and the one we have here is from New Concepts Engineering. Now, this particular charger runs off of 240 volts AC, which is supplied through this cable through the white, black, and green wires. The other 2 white wires on the AC supply the power to the shunt select relay. The charger takes the 240 volts AC and converts it to DC, which is supplied to the battery stack through these 2 wires here. The red goes to the positive side of the battery stack, and the black goes to the negative side of the battery stack. This is not the finished installation. When we are finished, this will be installed over to the top to cover the connections.
When a vehicle has power brakes, as this one did, those brakes are operated by a vacuum. When you pull the internal combustion engine out of the vehicle, you remove the source of the vacuum, so you have to replace it with something. In this case, we added a 12-volt vacuum pump right here in front of the charger and behind the headlight. That pump creates a vacuum in the reservoir that's right next to the pump, and then that vacuum is used to operate the brakes and, in this case, some other systems in the vehicle. One good printed source of information on electric vehicle conversions is this book called Convert It by Mike Brown. Mike's been converting cars for quite a few years, and this book contains a lot of his helpful hints. One section that we found particularly useful is the section on testing. We're going to run through some of these tests now before we actually put the truck on the road. Now, the design we've used on this truck is a little different from the design Mike used on the car in his book. So we're going to have to improvise a little bit on a few of the tests, but we'll be using his tests as a guide. First thing we're going to check is the battery circuit. With the circuit breaker off, it shouldn't be getting any voltage through the circuit. So we'll turn the circuit breaker off. Now let's check the voltage.
I'm showing about 3 volts on the meter. Of the 120 volts that is contained in this stack, that's very minimal. We're getting that feedback due to the fact we have other wires here leading to ground, which is running our meters and our chargers.
So that's about what we'd expect.
Yes, it's in safe parameters.
Okay, so now we'll turn the circuit breaker back on.
We're now reading 128.8 volts. That is the full voltage of the fully charged stack.
Now, in the next test we're going to do, Mike refers to using the main contactor, but we have 2 contactors, so what we're going to do is have Rich turn on the key and close the key contactor, and then we'll use the throttle contactor in this test. Okay, Rich, turn the key. That contactor's closed. We'll hook the meter up to the controller. Now, when Chuck connects the light bulb, it will go bright and then dim out. And the meter reads 128 volts. Now, when he disconnects that, it'll start falling. And it's gradually falling, and we'll just keep watching it here. It should fall back to 0, and then we'll go to the next test.
All right, now what we've done for this test is disconnected the minus lead from the motor. We've then placed the light bulb between this lead and where we disconnected it from the motor. What we're going to do now is turn on the system and energize it. If it's working correctly, this light should come on dim and then gradually grow brighter as Rich slowly increases his pressure on the accelerator pedal.
So then the light bulb will be acting like the motor would be acting if in fact it were connected up, right?
Correct.
Okay.
Rich, go ahead and turn on the key and depress the accelerator.
Okay, so this is as if the motor were just rotating a little bit, and now it's getting faster and faster, right?
Yes.
Okay,
now slowly decrease.
And now the motor is slowing down.
System looks fine.
Okay. Well, I guess we're about ready. Whoops, who's that?
Where's Dee?
How's it going?
All right, Dee.
Yeah, we're going to turn her over for the first time.
Oh, terrific.
Yeah, you're
Perfect
just in
timing.
time, yeah. Well, my friend Gerlinda gave me this special turtle for good luck at this moment. So we're going to rub the turtle, and Rich, turn on the key. All right, there we go.
Hi, Mary Ann. How's it going?
Hi, Rich, how are you?
I'm doing great. You about to wrap this project up?
I hope so. This is a list of all the things that were left to do, and we're just about to make our way through it.
I noticed that you've got a very comprehensive list that you've been using during the conversion. I was wondering if I could get a copy of that.
Sure, that one we had on the wall. I'm going to publish that and make it available to everybody that buys the video. I'll be happy to give you a copy.
Oh, great. I also have a couple other questions that haven't been answered yet. I wonder if we could go over a couple things.
Absolutely. Pull up a chair.
Thanks. I noticed while we were pulling the engine that the vehicle was originally air conditioned. Is it still going to be air conditioned?
Well, it's not right now because the customer didn't contract with us to do it.
It is possible, though, isn't it?
Oh, yeah, we can put air conditioning in it.
And how about heater?
Yes, there are a couple different ways to heat them. You can pull the original heater core and just heat the air as it goes through the ducts, or you can leave the heater core intact and use the little electric heater to heat the water.
I noticed earlier when I was looking at your truck, the Peach Crate, that it had a GE motor. Is the S15 also going to have a GE motor?
No, it has an advanced DC motor. It's a 9-inch, 23 horsepower motor.
And what about controllers?
My truck has a GE controller too, but the S15 is going to have a Curtis PMC.
I noticed that you retained the original equipment transmission. What about the clutch?
Yes, we kept the clutch too and the flywheel, although we did lighten the flywheel and take the starter ring off.
I noticed you went to an awful lot of time and trouble to design and manufacture the adapter plate. Is that entirely necessary, or does some company make adapter plates?
Yes, there are several different companies that make them. They don't all make them for all models of vehicles. You have to shop around. And we did it the way we did because we were on a short time frame and we really didn't have time to order it from somebody. They run from $400 or $500 to $7 or $8, depending on exactly what you get.
The other day when I was here, I noticed that the components on the high voltage plate were arranged in one fashion, and today I noticed that they're arranged differently. Why was the change made?
Well, we thought we had a pretty good design for the high voltage plate, and I didn't follow my usual policy of setting it all up on a piece of plywood first. I usually drill all the holes and bolt all the components down and run the cables out on a piece of plywood before I cut an aluminum plate to build it on. But we were in a hurry because of the rally in California, so we just went ahead and did it on the plate. And when I actually ran the cables, it turned out that some of them had to go around corners, sharp corners, and there was a danger that they might eventually fray. And so we redid it and put the components across from each other so that the cables could run just straight from one component to the other, and it worked out much better.
Although each battery is only 6 volts, connecting 20 of them in series creates 120 volts. Isn't there always a danger of sustaining a severe shock?
Yes, there really is. And in working on an electric vehicle, it's always very important to be very alert to where the electricity is and where it's running and what's connected and what's not. And in fact, earlier when I was showing you things about the batteries and about the high voltage plate, sometimes I had my hands on the components and right down in the connections. And when I was on the high voltage plate, I always was careful that either the batteries weren't connected or the circuit breaker was off. And when I was demonstrating the batteries, I may have had my hands down close to them, but never unless the batteries were covered with terminals. We have these terminal covers, that we cover the terminals with, red for positive and black for negative. They're always in place anytime that you're fooling around back there in the battery compartments. In fact, another important aspect of working on electric vehicles is to not work when you're tired or distracted. You know how it is working on cars. It's often tempting to just keep right on working through the night. And in fact, Bob Batson told me the other day that the night before, one of his customers had fried his controller in the middle of the night at 2 in the morning, I think was the time. And he didn't even have to say how, because we all know that you connect things to the wrong places when you're working that tired at 2 in the morning. Also, sometimes people will drop in to watch you work and talk to you while you work, and that's a bad practice because you start thinking about the conversation and lose track of what you're doing and connect things to the wrong places. It's real important to be undistracted and quiet and calm and rested when you're working on an electric car.
Mm-hmm. I also noticed that a number of electric vehicles have onboard battery chargers. Are there any specific safety precautions that have to be taken with onboard chargers?
Well, it's important to know what safety precautions are built into the charger. Some of them have a lot of fuses built in and ground fault interrupters, and in those cases you don't have to be quite as careful. The ones that don't have those provisions, you need to make sure that you add them and install them properly with all of the precautions you need. One, for example, that doesn't have a built-in ground fault isolator should always be connected to a plug that does.
So what are you doing with a silver pet carrier on your workbench?
Well, we've talked about transformerless onboard chargers. This is the traditional Lester transformer charger. This is an excellent unit. It's well made. This particular one is for the 72-volt Rabbit that I'm converting next. But you can see transformers are heavy. You can see why we don't carry it on board.
Oh, yeah. Notice that the cables connecting the batteries are quite large. Do they have to be that large?
That's 2-aught welding cable. It's quite large, but it needs to be this large in order to carry the 400 amp currents that these cars sometimes put out. And this is welding cable that I use. It consists of a lot of tiny strands of copper wire, which makes it real flexible. Some of the other types of cable, like this stuff right here, it's bigger strands of wire, and it's not nearly so flexible. It's harder to work with.
I know there's a number of different types of battery terminals in use. Which are the best type to use for electric vehicles?
Well, Rich, it's a funny thing. There are a number of topics in electric vehicles where you get different answers when you ask different people, and this is one of those questions. One of the most common types of terminal is the standard automotive terminal, just a round post, and you use this type of connector on it, and it's the type of connector you just screw down, just like on a regular starter battery. Lead has a property called cold creep, which means that when it's under pressure, it will slowly move and change shape. Some people like this type of connector because it gets a lot of surface area, but others don't like it because they say that the lead will cold creep and loosen up when you're using this type. So you have to be more careful about tightening your battery connectors more often. There's another type of connector that's just a post. It's just a post with a hole in it that you put a screw through and use an eyelet type connector to connect it. And you use a Belleville washer, which is a curved washer, and when the lead cold creeps, that washer will kind of let out a little bit and keep it tight. Mike Brown especially favors that particular type. The third type of terminal which you don't want to use is the type you usually see on golf cart batteries, which has a little automotive post then with a stud sticking out of it, and you use an eyelet, you put it down over that stud and screw it down. That type is particularly bad because of the cold creep, because when you tighten that down, that stud will eventually creep out and actually loosen up and can cause a battery fire.
The day you brought the truck in, you took measurements of the ride height, and then later you took measurements in the engine compartment. I was just wondering how the measurements compare now that part of the work is done.
Oh, it came out just about perfectly. The ride height was exactly the same in the front, 1 centimeter higher in the back. I've got a really good spring guy. He knows what he's doing. And as far as the engine compartment, the measurements were none of them were exactly the same, but they were close enough tolerances that it'll be fine.
I guess that's all the questions I had. I just hope I get a chance to see it before you deliver it.
Well, I'll do my best. Well, Chuck, as soon as we get this high voltage box bolted together and get it on the truck, we'll just about be through.
Good.
So I thought you were going to make that out of the white polypropylene, Mary Ann.
Well, ordinarily they will be polypropylene, but we made this one out of plexiglass because the electric company is going to show this truck a lot, and they want people to be able to see the wiring.
Oh, okay.
And we have the neoprene cover on the batteries now to keep dirt out of there, and also people's hands. These are the last two safety features in the front, and all of the high voltage components are now secured.
It looks really good.
Good. I think they'll like it. Let's take a look at the back.
All right.
And this is what it looks like under the bed. We have the welded polypropylene boxes in place, the neoprene covers covering each bank of batteries. Ordinarily, when the truck is in operation, all of these batteries are covered, all the covers are in place, but you can roll each one back one at a time when you need access to those particular batteries. The covers serve two purposes. One is to keep dirt out of the battery boxes and keep them nice and clean, and the other is in the event any acid gets out of the batteries by bouncing along or any other means, the covers keep the acid off of the underside of the bed. Well, so there we have it, a completed electric truck.
You know, Mary Ann, this truck turned out really nice. I do believe that the folks at Arizona Electric Power Cooperative are going to be very pleased with it.
Well, I guess we better start getting it ready to deliver. But first, I need to take somebody for a ride. Hello?
Well, hi, Mary Ann. What a surprise.
Hi, Rich. How you doing?
Doing great. How are you doing?
Hey, guess what? I got a surprise for you.
What's that?
The truck. It's all finished. I got it out here.
Really?
You want to go for a ride?
Oh, I'd love to.
Okay.
Oh, the truck looks great.
Yeah, you see we got that armor lining coating in the bed.
That looks really nice. How does it run?
It runs real well. I'm real happy with it. It accelerates better than it did with that old V6 it had in it. And I've had it up to 70.
Oh, that's a real nice setup on those gauges. And I see you've got your Mothers Against Drunk Drivers ribbon.
Oh, yeah, we're very strong on that.
Ever-growing numbers of auto owners are switching to a clean electric ride. They are foregoing fossil fuel. They are adapting to an ever-improving technology, and they are helping to reduce the pollution in the country. All over America, electric vehicles are rolling along, in the suburbs, on small-town streets, and down country roads. You'll find them on big city boulevards, on interstates and freeways. These quiet cars and trucks are moving ahead environmentally, creating a quiet revolution.